First of all, thank you so much for having me and Federico here. It's really, really a pleasure. So, just give me a second so I can share my screen. Okay, can you see it? Can you see something?
Yes.
Yes.
Okay, fine. All right. So maybe I should introduce myself first. I am Matteo. I've been a Max user for 10 years or something like that. And I'm also a Jitter guy. So I'm really passionate about everything you can do with images and videos inside Max. And recently I got involved by the Jitter development team, working on some new toys and objects that has been released with Max 8.3. And I'd love today to show you some of these new objects and functionalities together with Federico. And so what I extensively worked on is a new object called gl.pbr. Maybe some of you already tried that and know what it is, but for who don't, I'm going to give you a pretty rough explanation of what PBR is. Even if you are relatively new to Max and Jitter, probably you came across the object GGL material, I guess. There is a very nice material editor you can attach to whichever 3D shape you wanted. You can decide and define some features and characteristics for that object. And you can also decide the set of equations you can use to simulate, or better to compute, how the light interacts with the surface of that object. gl.pbr does the same thing. So you can use it to define some material features. You can create some materials. But the key thing behind gl.pbr is that it does so considering how light interacts with objects in the real world. So it implements a set of functions that kind of mimic the way light interacts with objects in our world. So that said, I'd like to start from a blank page, and I'd like to build it together with you so that I can make a sort of walkthrough of the object and its functionalities. And I also like to give you some hints, tips and tricks on how to get the most out of it. So first thing first, of course, we are talking about something related to 3D rendering. So the first thing to do is probably to create a JIT word. I'm setting here the attribute at floating 1 just to have the window always in front. All right. And now let's draw something. So let's create a GGL grid shape to start with. I don't know. Let's make a torus. So shape torus. I don't know why, but maybe because I like donuts. And then let's also set here the dimension for this torus. Let's go for something quite big, like 50 by 50. So we have plenty of triangles. Okay, here it is. If you want to see that better, we should move the object or move the camera. So I'm going for the latter. So ggl.camera. And what I usually like to do, at least to start with, is to make so that the camera always points at the center of the scene. So I like to give the attribute at lock_look1 so that the camera always points at a specific position in the word. And then I also set here the attribute at tripod1 so that as you move the camera, it doesn't roll in weird ways. And to conveniently move this camera here and there, I usually use g.animDrive with the attribute at UI_listen, which let you use some keys on your keyboards to move the camera, namely WASD-X for moving the camera here and there, and then Q and Z to tilt the camera up and down. All right, so here it is. Now, as I said before, if you are familiar with GGL material, you know that you can simply take it and attach it to whichever shape you want, like this. and it gets immediately colored this way. Now, this is no magic, of course, but what happens is that there's a shader that gets automatically generated and gets assigned to this GGL grid shape. In fact, if you want, you can also see that with the message get underscore gl3 shader. You can have a sneaky view of the content of this shader. Okay, here it is. Well, gl.pbr works exactly the same way. So you can create this object, gl.pbr, and you simply connect it to whichever shape you want to treat with this set of functions. And here as well, you can send the very same message if you want to geek out about the content of the shader. Okay, so by default, you can already see that something is going on with this shape. Maybe I should make my window a bit larger. Okay. But as you can see, this object, exactly like GGL material, has a bunch of inputs. Each one of these can be used to create some effects or to control some features of these materials we are generating. But I'd like to start all over to the right. This input is called environment input. Now, you must know that gl.pbr implements what is known as IBL, that stands for image-based lighting. Those are a set of techniques to use an image taken from the real world and use that pieces of information to spread some colors on our mesh. Typically, these images are a very wide image, usually rectangular, and contain a sort of 3D, a sort of 360 photo of a given environment that may be, I don't know, a room inside or a park in a sunny day, whatever. But this gl.pbr object lets you create a mesh that interacts with the light coming from an environment map. So usually what I like to do is to display such environment on the background, so to have a better sense of the scene we are building. And to do so, we can create a GGL cube map object. Now this one is an object that can create a sort of cube around the viewer, and each face of the cube is colored with some portions of that environment map. Now, since 8.3, you can directly send the message read to this object and load in an equirectangular environment map. Since I want to make things easier, what I like to do is to create a drop file object, so to simply drag and drop an image. And then I write something like read $1, bang. And this way, we should be able to drop in an image and get it stored inside GGL cube map. Now let me pick one. Here I should have something now, sorry. Wrong folder. Okay. Maps. Okay, here it is. Okay, I just take one. Okay, and it's loaded, no errors, so that's fine. But as you want to display that environment on the background, you should use another object in conjunction with this GGL cube map, and such an object is GGL skybox. This object I usually like to give the attribute at infinite 1. So to project this background as it is, yeah, infinitely distant from the viewer. And now we can simply connect GGL cube map to this object and send a bang again, or drag and drop again the same environment map. It takes a while, at least the first time, but okay, here it is. Now you're free to navigate this scene, having in the background the content of this environment map. But as you can see, it looks kind of weird because the colors look oversaturated. You have some pieces of the image that are quite burnt out, or some areas which are too dark. But this is normal, and this depends on the fact that such environment maps are high dynamic range images, while we are trying to display those on a low dynamic range monitor. So to have a correct display of the colors, we should add something else. We should add another attribute to ggl map named gamma correction. And we simply need to set 1. Now, of course, we have to drag and drop it again. And this time, if everything works, okay, now it looks better. Now the colors are correct. Okay, fine. So now we are able to see the environment, but of course the light is not interacting with our object yet. So to make it interact with our mesh, we should plug in the rightmost inlet, the very same environment map. But to do so, we need to use another object, which is called git.openexr. EXR is nothing mysterious, it's just the format for this kind of images. So every time you may, for example, download those from the internet, you will always find this kind of format if it is a high dynamic range image. So what I like to do is simply to take the very same patch code, since the message is the same, read followed by the path to the file, and then a bang. This object, if you never use it, behaves kind of like JIT metrics. That's really quite the same thing. It just deals with this other kind of format. And now for the third and hopefully last time, I drag and drop again the same image. Okay, and now we can see that the light is interacting with our mesh. To prove you that, you can see that down here we have a fireplace, and if we move the camera back here, you can see that we have a sort of reddish tint on the back of this torus. And that's because the light coming from this direction illuminates the back part of this shape. Okay, so this may be a basic setup, but from now on we can tweak some control parameters to have a different kind of material response. And the two main things that you should care about are two parameters called roughness and metalness. So let me bring those out. Let's go here, roughness, which by default is 0.3, and metalness. Whoop, okay. So let's start from this one, from roughness. This is a parameter that you can use to decide how rough is the surface of this object. It has a range, a valid range, that goes from 0 to 1, and getting closer to 0, you get a pretty smooth material. As you can see, we have these reflections that are way smoother, while if you go towards 1, the object becomes more like, I don't know, rubber, or anyway, a rougher material. So just with this one control, you can already achieve a massive variety of different believable material, I'd say. But the second parameter you should care about is this other one, metalness. This one is a floating value, but take care about this one. You should treat this one as a sort of Boolean value. So material can be metallic or non-metallic. So you should always plug in here 0 or 1. At least you should plug 0 or 1 if you want to have a physical response out of this object. Otherwise, of course, you are free to experiment and do whatever you want. But to recreate exactly physical behavior, you should plug in here 0 or 1. So what you can see is that as soon as we put 1 in here, the object looks like a metal object. And even with metalness set to 1, roughness continues to work. And we can get a rough but metallic reflection this way. So these are the two main parameters you can control with gl.pbr. But of course, if you want to create complex materials, we can also use something else. In fact, here you can see we have a bunch of inputs. that can host some so-called material maps. So some images that describe how a certain material is made. For example, let's start from the left. Here the first one is albedo, also known as diffuse or base color. So here you can plug in any matrix that contains an image representing the base color for that mesh. Let's make an example. Let's create a JIT matrix. And again, same thing. So drop file followed by the message import movie $1, bank. Okay, so it hopefully becomes easier to drag and drop some images. And here I have a list of maps. I just downloaded those from the internet. You can really find tons of different materials online. And let's start from this one, from this red image. So drag and drop it in here. Okay, you can see that it gets applied in the form of the base color for the shape. And still all these parameters continue to work. So you can go back to have a non-metallic object, and still you can play around with this roughness param. But of course, there are several other things you can control this way. So plugging in some images, some maps, material maps. Let's make some room for some other friends. So let me copy this one over here and let's plug it in the third inlet. This one is roughness. So in here we can load a roughness map. So another image that is usually a black and white image that must be read this way. Whenever you have a white color, it means that the surface is very, very rough in that part. Whenever you have something closer to 0, so to the color black, the object is very smooth. So let's drop in another map. Here, let's take this one. By the way, we can also create, just for the moment, a JIT window if you want to see what we are loading. So let's send the bank here. Okay, this is the map. So as you can see, pretty simple, but this way, let's set the roughness to 1 and let's see what happens. If I get close to the shape, you can see, hopefully, if the video compression is not ruining everything, you can see that some parts of the shape are rougher than others. So this way you can convey a better sense of realism applying such maps. But even when using roughness map or other maps, this parameter roughness continues to work. So this one becomes a value that gets multiplied by the values contained in this map. So if you want to use the exact content of this roughness map, you should leave roughness to 1. Otherwise, you can try to play around with it if you want to affect the material in different ways, but of course the roughness stays proportional to the content of this roughness map. Okay, so let's move on. I want to show you some other inputs that are available. So let's change material. This is a pretty simple one. Actually, it comes with just 2 maps because it is supposed to be a sort of plastic material. But of course, you can have something very, very different. Let's try with something else. Let's go for this one. Okay, so let's drop in the albedo and the roughness. Okay. This is the new material I'm trying to simulate. But as you can see, this material should not look as flat as the one we saw before. For this reason, there are several other maps we can use to convey a better sense of realism. So let's create another JIT matrix and let's plug in something else. Now I'd like to drop in a so-called normal map. So maybe you already saw such maps. This one, okay. These maps are nothing more than an image representing the orientation of the surface. So usually they look bluish, but that's just because these maps are conceived as if the surface were pointing towards the viewer, and the blue, being the z-axis, always look quite well, the image looks quite bluish just for that reason, because usually the surface is pointing towards us. So dropping in a normal map, the effect is that now light behaves differently, because you can mimic all these little bumps and discontinuities on the surface of this object. To give you a better idea, we could also try to map these textures quite differently. If we bring out another attribute called text repeat, we can control the amount of texture repetitions. So if we increase these values, you can see that it gets repeated more and more. Okay, this is beneficial also if you have a quite small texture that you want to repeat all over the shape, across all the shape. Okay, so with normal maps, we have a better interaction of the light with the surface of this object. We can sort of simulate all these bumps on the surface of it. But if you have an object that shows quite a lot of these peaks and valleys, there is another nice mode you can use to achieve the same, if not better results. So let me show you another thing you can do with this gl.pbr. If you scroll all these attributes, you should find something called Parallax. Now, if you enable this parallax mode, what happens is that this gl.pbr object starts to behave completely different. So let's enable it. You cannot see much of a difference actually at the moment, but what is going on is that now the normal map gets completely ignored. And what happens is that all these bumps now depend only on another map called height map. Let me show you it. Let's create another matrix connected to the height input, and let's drop in a height map. Okay, here it is. Okay, and let me show you how it looks like. GP window and bang message. Okay, it looks something like this. This time, every time the image is black, that's a valley. Every time it is white, that's a peak. So you can already see that something is going on with our object. You can see that some parts of the shape are now detached from the rest. And those parts correspond to where the height map is brighter. But we can increase even more this effect by taking another attribute called high scale. So let me take it. Okay, here, high scale. By default, it is set to 1, but you can increase it and have this sort of deformation of the shape. So as you can see now, we have many more details, and the shape, the surface of this shape looks way more 3D. It can be seen even better if we change the shape we are using. So let's pass from torus to open cube. Okay, we cannot see anything because, okay, that's an open cube. So part of it is entirely open. And let's also go back to another other values for this text repeat attribute. Okay, as you can see now, you have the impression of this of having a sort of 3D surface. So consider this: to simulate the same thing, you would have to create tons of triangles. But this way, this is a convenient way to replicate the same effect while in fact having a very pretty limited amount of triangles we are rendering. This is possible because this parallax mode allows for a combination of polygon rendering and ray marching. So all these small little details on the surface of the object are simulated, or better, are rendered using ray casting techniques. And this is called parallax because, as you know, parallax effect is that kind of effect that is related to distances and movement. If you have two objects, one is closer to you, one is far away, and you move left to right, you see the closer object moving faster than whatever is far away. And this kind of parallax effect replicate the same thing, giving the impression of such a 3D surface. Okay, but this parallax mode allows also for something else. Let's try to bring in a light. Up to this moment we saw gl.pbr interacting only with environment maps, but of course you are not limited to that. You can also use gl light as usual. So let's create one. gl light. Let's go for, I don't know, whatever kind of light you prefer. Let's go for a point light. So add type point, add position 221 or something like that. Okay, we can see something. And now let's talk for a second about the color of this light. Maybe you are used to set the diffuse attribute at diffuse using values, I don't know, maybe something like 0.9, 1, 0.3 or something like that. Anyway, floating values that represent typically the color of the light. But in the context of PBR, so physics-based rendering, these should not be considered as the color of the light, but rather as the light intensity. So feel free to set here values that can exceed 1. So for example, you can set 10, 13, 4 or 4. That's totally legit because this is not the color anymore, but that's the amount of energy that this light produces for each component. So the amount of red, the amount of green, and the amount of blue light. Okay, so we can see that now we have this sort of yellowish light. And I'm doing this because I'd like to show you another feature that comes with this parallax mode enabled. If you again go among these attributes, you should find something called self-shadow. Self-shadow is an attribute that you can activate. Okay, and it should show some self-shadowing. Now, this is quite different from the shadows you can cast using the attribute shadow from GGL light, because those shadows do not work on the surface of the object itself. So they do not consider if there's something potentially occluding the light on the surface of the object itself. But with self-shadowing, in conjunction with this mode enabled, you can control, you can cast some shadows on the object itself. And of course, shadows do respond to the amount of high scale you want to apply. By the way, something I forgot to mention is that if you go for negative values with this height scale, you basically invert the height map. So where are valleys, now there are peaks. Okay. Now, this process can be quite heavy on the GPU. For this reason, if you look inside the help file, you should find under the height map tab these quality presets. This is something that I prepared, hoping to have something easy to set and to change the quality of this parallax effect and the quality of the shadows. They range from low, which is kind of ugly, to no real time, which is the best, but of course it is quite heavy. As you can see, the rendering gets painfully slow. But if you search for something in between, you should be fine with it. Okay. So this is it for parallax effect. So just remember that whenever you want to have this kind of displacement and bumps on the surface of the object, you should enable parallax, which implies that the normal map gets ignored and instead everything depends on the height map. And once you enable parallax, then you can play around with this param, height scale, and with self-shadowing to get this nice soft shadows on the surface of the object. All right, now I'd like to show you another functionality of this object. Let's go back to the default state. So let's disable parallax, and let's try to apply this material to something different. Let's try to bring in a 3D model. So let's create a gl model. I'm going to load the classic doc file, so at doc.dae at matrix output 1, because I want to send out a matrix from this gl model, and at automatic 0. Okay, load bang, or simply a button as you prefer, and then gl.mesh mesh at draw mode triangles, since we are using a model. And well, that should be it. Okay, so let's double click on it and let's disable this grid shape. So where is it? Enable, voila. Okay, and here we have the dock. Now, if we want to apply the same color, we should, of course, as we would do with a GGL material, we should take this patch cord and connect it to this other mesh. Now, I'm using this model because if you ever try to apply a texture on this dock, you know that that's a nightmare, because the UV coordinates, the texture coordinates are all over the place. But with gl.pbr, there is another mode that you can use to create from the scratch texture coordinates. So if you go here and look for, where is it? Texture coordinate generation, this one. By default, that's set to none. So this means that the coordinates from the model or from the grid shape or whatever are used, so what you already have. While if you select one of these two options, biplanar or triplanar, automatically the texture coordinates are generated from the scratch. So even if you have a model with very ugly looking texture coordinates or a model with no texture coordinates at all, you can still use this kind of texture coordinate generation if you want. Triplanar is the same, kind of the same thing of biplanar. The main difference is that biplanar is slightly more efficient, but it doesn't use normals. So as you can see, as I switch from triplanar to biplanar, all these bumps are disappeared. While triplanar is a bit more expensive computationally, but the results look better. And even with this text gen mode applied, you can still play around with this text repeat attribute and have whatever amount of repetition you want. Okay, so yeah, this is the basic functioning of this object. Just a couple of words on the other inputs. Here you have a metallic map that of course you can use whenever you have an object, material that has a metallic part and a non-metallic part. So if you want to combine the two things, you can use a map to do that. Or this other input that is called ambient occlusion that you can use to plug in an ambient occlusion map. So, well, let me show you that. Probably it's better if I show you how it works. So let's create another matrix. Let's move this one here. Okay, this one, ambient occlusion. So usually, as any material has some bumps here and there, usually it comes with a pre-computed occlusion map. That looks something like this. Let me show you how it looks like. Okay, looks something like this. Occlusion maps work like this. Whenever you have a darker color, it means that that part of the shape is supposed to be concave. So it should receive less ambient light, that is the light coming from the environment. While on the contrary, wherever this map is brighter, that means that that part of the shape is supposed to receive light from every direction. I don't know if you saw as I plug this one in, but all these parts of the shape that are concave now got darker as they do not receive the same amount of light as before from the environment. So, to make a long story short, whenever you want to simulate a complex material, all these pieces of information can contribute to create the puzzle. And whenever you have a material with a quite evident amount of valleys and peaks, switch to the parallax mode and play around with that. And the last one, the last input, is called emission. Now this at the moment is a sort of placeholder. We did not create any system to support emissive materials, but we are working on that. So hopefully this will be useful sooner than later. And yeah, I guess that's it for this walkthrough. I don't know, maybe if you have any question, I'm more than happy to answer you.
Anyone got any questions? Or we could maybe do the questions in the breakout rooms later on. I have one question,
Okay.
if I may.
Okay, sure, go for it.
I was playing around with gl.pbr, and I found this. I wanted to make my own environment map, and I found this really good app called HDRI, as in I. Mm-hmm. And I was able to take like a 360 photograph of my front room and get it into Max. I was wondering if you know of any like good applications or places online where you can upload a photo and get your normal map, your height map, your ambient occlusion map.
Yeah, I know a free software to do that. Let me think about it. I don't remember how it's called. Something like bump generator, maybe. Maybe you, Federico, know it. Let me look.
Maybe the Crazy Bump?
Crazy Bumps, yeah. Crazy Bump. That's a really nice piece of software. You just drop in an image and it automatically creates for you normal maps, occlusion maps, height textures, and yeah, all the maps you need. And that should be free. I don't know if it runs only on Windows or on Mac as well. Not sure about it.
Okay, great. Thanks for that. Yeah, fantastic presentation. This is definitely an exciting development in Max. I've been exploring this quite a lot and having a good time. I'm guessing also that because these are all matrix inputs, there's room to sort of generate some of these maps in real time with like gl.bfg or something like that. And
yeah, for sure. In fact, the presentation was actually not over. I'd like to show you how to create some materials procedurally, because that's the fun part, of course. Also because in a recent update, now gl.pbr supports texture inputs. So all these maps can now be provided in the form of a texture. Hence, you can benefit from, as you Ned said, from, for example, gl.bfg, so generate whatever kind of crazy material you want on the fly. Yeah, let me bring up the other patch so I can show you an example. Don't save, I don't know. Yeah, maybe save. Who knows? Okay, basic p gl.pbr. Okay. So this is another patch I'd like to show you. Give me just a second. I have to drop in a map here. Okay. And we should be good to go. All right. So this is an example I put together to show you how you can create some materials procedurally. Just a second, sorry, I need to check if everything works. Okay. Now, here, well, first give a look at the patch. Now, then I can explain to you everything. Basically, here you're looking at a terrain colored using gl.pbr, and all these parts, all these shapes are created using the Parallax mode. Let me use a higher quality preset. Let's go for ultra. And yeah, here I'm using simply gl.bfg to generate this sort of shapes. And this patch, I made this mainly to show you how to create materials with this procedural approach, but also because this patch is audio reactive. So I created a track here. Yeah, probably I should open now the channel from here. Okay. Okay, and so on. It keeps repeating. Okay, so what I find interesting with this approach is that you can generate whichever texture you want, and you can use that to control basically all the features of gl.pbr. Let me show you what I'm doing here. So this is the PBR object. I don't know if you can see it, otherwise I can zoom in a bit. So this is the PBR object, and as you can see, I'm simply controlling three things. First, here I sent in an environment map, and then I'm sending in two textures, one for the height map and one for the albedo color. So, of course, the responsible for all this movement on the surface of this mesh is this height map texture. And basically from this gl.bfg, I'm deriving everything I need. The reason why you can see two different colors, let me switch back to noise cell. The reason why you see two different materials basically is that inside this gl pics, what I'm doing is that every time the height is 0 basically, show this texture, otherwise show the white color. So this way you can also combine two or even multiple materials in the same context. And yeah, there are some quite a lot of things going on in this patch that I'd like to discuss about. Some tricks basically, because the basic function is exactly what you saw previously. So I have parallax enabled, parallax shadowing, self shadow, and that's it. All the interesting part comes really from a couple of tricks here and there. So first of all, what I'd like to point out is the use I'm making of this noise, this one. So I said that I'm creating this height texture procedurally using gl.bfg. But if you look closely, you can see that the surface of this object looks quite rough. I don't know if you can see that. And that's because I'm combining the, I'd say, primary height texture with the secondary height texture generated using this JIT noise. So I want to give a very small texture, a very, I'd say, detail to the surface. And I'm doing that using a noise. And if you look inside this gl.pix, you can see that it gets multiplied by a very, very small value. Otherwise, it would look something like this. Okay, that is definitely too much. But of course, going under this multiplication, the effect is pretty much smaller, but it gives you this nice little touch of realism, I'd say. It looks good in my opinion. But the trick comes here. You can see that this noise is going under a division, and the divisor is nothing less than where's it? Okay, this one, the height scale value. So if you think about it, every time we increase this high scale, what happens is that the parallax effect becomes more evident, right? But if you apply the same high scale also to the noise, it means that also this little noise detail becomes more evident. While if you divide this noise amount by the high scale parameter, what happens is that it always stays at the same level, no matter the fact that we are actually modifying this high scale, so the amount of parallax to apply. So this is a nice trick, little nice trick, but it works quite good in my opinion. And another thing that I usually like to add when using procedural textures like this is a little touch of blur. So blurring effect, because otherwise, I don't know if you can see that well now, but what happens is that, especially when using low settings for this parallax mode, what happens is that you get a lot of aliasing. So with just a touch of blurring, you should be able to get rid of most of it. And besides, you can use blur to control the amount of, yeah, from rigid to these kind of bubbles. So it's also fun to have as a control. And then to give a finishing touch, sorry, let me stop the audio and also this camera that is getting me dizzy. Okay. So maybe you can also see the noise better. Here on the left of the patch, I'm using a series of GL passes. Now, I guess you already know what this object does, but if you don't know, it implements a series of effects that you can apply on a 3D scene after it gets rendered. So typically, the max setup to do so is to use a GGL node object using the attribute addCaptureTree to capture not only the color of the scene, but also some accessory information, such as normals, depth, so the distance of each fragment to the viewer, and velocity, that is the amount of displacement each fragment went through from frame to frame. Now, if you use this GGL node using this addCaptureTree, you're free to create a series of so-called pass effects. These effects range from motion blur to depth of field and many other cool stuff like this bloom effect. And usually these are sort of post-processing pass. So to give a nice touch to the scene, you can always use these passes. If you want to give a look at how it looks like without those, let's try to remove, no, this one we shouldn't. Okay, now it doesn't make much of a difference because the image is static, but as soon as I make it move somehow, you should see that the motion blur doesn't work anymore. But yeah, that's something silly. That's just a, stylistic choice, I guess. But that's something I usually like to put in my rendering. But something important that must be pointed out is that whenever you use pass effects, something you should do is to go in gl.pbr and make sure that this attribute called gamma correction, where is it? Gamma, okay, here. Okay, I was saying this one should be disabled. this is pretty much important. Why is that important? I don't want to go too much in detail about what gamma correction is, but what I should say is that you must know that your monitor, your display, the display of your computer is not neutral when it comes to displaying the colors. What I mean is that if you have, let's say, a grayscale ranging from black to white with 0 corresponding to black and 1 corresponding to the color white, you would expect to have a middle way gray in correspondence of the value 0.5. But this is not what happens in reality. This just depends on the way our eyes perceives luminosity. So what the computer screens do is to adapt this curve to how the human eye perceives colors. And this is perfect. I mean, that's really, really convenient. But the problems may arise whenever you try to simulate how the physical light interacts with the objects. So, by default, this gamma correction is on. This means that whatever comes out from gl.pbr works, and that's already gamma corrected. But if you plan to add some other pass effects, you should disable this one, and then as the last step of the chain, you should include this other pass effect called simply gamma. You just plug it in, set and forget. But if you do so, the colors are displayed correctly, otherwise they look like this. So you can decide. You can activate gamma correction here, which is on by default, but then you could of course use GGL pass effects, but the result doesn't look correct. Or you disable this one and make sure to include as the last step this other this other pass called gamma. And yeah, anyway, I'd like to pass you this patch so that if you're interested in how it works, you can play with it, explore it, and study whatever. And yeah, I guess that's it. I guess it's time to pass it over to Federico. I don't have much more to say.
Okay, thank you very much, Matteo, for the awesome presentation. I actually would like to add a couple of things about your presentation, which I think you are too modest to mention. One thing being that the sound you created was actually created only using Max built-in samples, the track you created, which is awesome. So it's about the samples being modified in Max and being connected into a track that actually looks pretty good, which I could not make in Ableton myself. And then actually, I think it will be cool to show the video demo you made for gl.pbr.
Oh, yeah, you're right.
Or at least to send a link to it.
Sure. I don't know if you can send a link to it because I don't think it's uploaded somewhere.
Okay.
But
okay.
yeah.
That would be actually cool to give it a look, because I think it's really cool and it shows what are, in a very short time, what are the possibilities with gl.pbr, and I find it extremely cool. So yeah, I pass it back to you.
Okay, thanks. Yeah, just one word about the video while I'm searching for it. I created this this promo video before we knew that the Parallax mode would have made it in the first release of gl.pbr. So you won't see any of that applied. But anyway, it can give you a brief idea of what you can achieve with it, what sort of materials you can create. So sorry, give me just a second. I totally forgot.
Sorry, I didn't want to put you on the spot, but I really appreciate it so much.
Okay, so I share again my screen, and okay, I'm activating my playback from the computer, so probably if you talk, you can hear the feedback. Okay, do you see my screen again? Can you see it? Okay. Can you see the video when I go full screen? Can you confirm that? Okay,
yeah,
fine.
I see it.
Thanks.
Thank you so much. I love this video.
Okay. Thanks.
Yeah, so thank you again, Matteo. This was really cool. I also learned a couple of things which I didn't know about the PBR. Actually got a couple of questions for you, but I think we can do this later. And yeah, hi everyone, I'm Federico Foderaro. As Matteo, I am a long-time Max user, and especially in Jitter. I have this YouTube channel called Amazing Max Stuff, which some of you definitely know. And I as well work with cycling since some time, and we are working on the Jitter tools packages together with Matteo and Robert Ramirez and some others. So I'm going to show you today some some new objects and some additional features of existing objects. So let me share my screen. All right. Can you see my screen? Okay, awesome. Cool. Do you actually see? Okay, let me reduce that. Do you actually see yourself in my screen if I leave the zoom bar here?
No, I can't. We can't see Zoom, but I can see the screen. Yeah.
Thank you. I'm a Zoom knob. Cool. Actually, these are the new Jitter features available with Max 8.3. There is some things that we are still working on and some things that are already available. So one thing is the gl.pbr, which Matteo just shown. The other feature which I'm going to show you in 1 second is the gl.meshwork masks. So the ability to create masks using the gl.meshwork object. Then we got the gl polymovie and git polymovie and the gl texture set. These two objects are actually already in Max since 8.2, but they were not given so much space, so I think it's cool to introduce them again. And then Git gradient UI. Now, in the future, we got some new gl pass effects, which are really cool, and Matteo is going to show them later. And then I'm working on a gl.text.multiple objects because some of the people requested the ability to create three-dimensional text in a more kind of more performant way, because at the moment to do that, you have to create a lot of gl text objects and it's very inefficient. So I'm working on a solution to that. First of all, I'm going to show you the gl.meshwork mask feature. So I've made this little demo, which is about a bunch of videos being masked and placed inside the JIT window in a way that they represent this creepy face. And I'm going to show you now how masks work in gl.meshwork. So let's do like this. Let's create a new patch. It's going to be very brief because it's a very simple feature to use. So first thing, as Matteo did, I'm going to create a JIT world with floating one. And I'm going to enable it. And yeah, that's it. Then we need gl.meshwork. And one thing that is needed for masks to work, which is actually a bug, I'm going to fix it soon, but is it to give it the show UI one attribute when we create the gl.meshwork. Otherwise, the masks will not work at the moment, but this is going to be fixed soon. And then I'm creating a JIT movie to which I give output texture set to 1. So it's going to output a gl texture and not a matrix. So every time we actually want to work in movies in Max, this I'm still stressing it because I still see this happening once in a while. We never want to use matrices when working with movie. We want to use textures. So always output texture set to 1. I'm going to set volume 0 just in case there is some volume in the movies I'm going to load. And cool, now I'm going to then just import a movie inside this JIT movie object, just drag and drop it. And as you can see, it's being rendered inside the gl.meshwork plane. Now, gl.meshwork is not a new object, so I'm not going to describe it from scratch, but just for The ones that are unfamiliar with it is an object that allows to make video mapping. So basically you have all these little dots, which are displaceable, which are movable. You can move them around in order to, for example, make some video mapping and map this video to a surface with which is not flat. So if a surface is not flat, it's going to introduce distortions in the video. And with this object, you can actually change the appearance of the video, so to eliminate the distortions. But you can also use it actually in a creative way, just to place some videos inside the screen and distort them. We can have also more of those meshes. Oops. More of those vertices in order to have more points to play around with. I actually had to check how to add more of the mesh div. That's the attribute I always have to refresh that. Because there's actually an object that is not new, is around since a while. So, oh, I connected to the wrong one, of course. So yeah, we can have more of those dots. So this allows us to have a more precise displacement of the parts of the movie. Okay, so that's the meshwork object as it is until now. There's a bunch more features, but that's mostly it. And I'm going to show you the new feature, which is the masking. So I'm going to the help file. I'm going into mask mode, which is this new tab. I'm going to copy all those messages, passing them inside my patch. It's a bit, my screen is a bit filled, but that should be okay. So I'm going to connect all those cables to the gl.meshwork. And we have a bunch of messages, those being mask mode to actually activate the mask mode. So let's see. If I click on mask mode, it's going to activate the mask mode. As you can see, the video became a bit darker, which means that now if I shift and double click on these, it doesn't work. Okay, so sorry, let me check. There was another attribute which I should use to enable the mask mode from working. So this should have actually been called the debugging Jitter 8.3 with Federico and Matteo, because that's actually what most of the time goes on. Okay, so what's your problem? Okay, now maybe the layer attribute is necessary. Okay, I got to check what's the matter with it, but basically now I can shift and double click and I can create those squares or rectangles, depends what's the actual ratio of the video. And these are actually my masks. So I can use those to mask portion of this video. So if I go here and I say apply mask, you can see that now the video is being masked. I exit mask mode and I just masked part of this video. Can go back in mask mode, invert the mask, apply the mask, and now I basically got rid of the portions mask. So I inverted the mask. I can reset the mask and it should actually delete the mask. So then I can go back in mask mode and create some more masks. One cool thing is that to make the mask a bit more precise, I can shift click on the edges of a mask. This will create more vertices, which allow us to make the mask more precise. So we can have a better definition for our mask. And we can move the mask by command, clicking on this blue dot. And this is going to move the whole mask. If I want to get rid of a vertex that I created, I just shift click on it. And we also got the command Z and so the redo and undo also in the masks. So I can undo actions that I have done and I can redo them by pressing a command Z or a command shift Z. Or actually, yeah, exactly. On a MacBook, on the Windows will be command Y. So that's that's for masks. We can, in this way, create some nice effects. We can use this for video mapping, of course, if we have to mask portion of a video on a surface. And I can delete the vertices by shifting, clicking on them. I can delete a whole mask by shifting and clicking on this blue dot. And this is it. Can apply the mask, and that's it. Invert it. Cool. And in this way, I have created this the face demo thing. So this is one thing that I'd like to add to this is the blur on the masks. This is not a thing at the moment, but it's probably coming in some future releases. Cool. So I'm not really going to save that, but I can share with you the dispatch, although you need the video for it, so it's actually not really useful. One other cool object that I actually used in tandem with the gl.meshwork to work on this patch is the gl.polymovie object, which is actually, it does something that is really so basic. It's really such a basic need in Max, and it was possible to do that before, but this object makes it much easier. So it allows us to read a folder of videos. Let me actually isolate that in a new patcher. It allows us to read a folder where there are some videos. For example, I got this folder here where I got these 6 videos, which I use for my demo. And we can play them all at once from the gl.polymovie object. So it's like a JIT movie object, but allows us to play multiple, to read and to play multiple movies at the same time. So on one side, what we can do with it is to just select a video to play. For example, we can say play 1. First, let me read the folder. Good. Then I say play 1. And of course, it actually needs a JIT movie to work. Sorry, a JIT world to work. Otherwise, it's because it's a GGL movie object, it's a gl.polymovie. It's not the matrix version, so it needs actually a JIT world to work. So let me actually enable that. Cool. And as you can see, it starts play the first video. I can then play the second video. And as you can see, there is really no delay between the 2 videos playing, which is something that if we would have a single JIT movie object and we will load the movies every time we want to play them, this will result in a delay. But in this way, it's actually super fast because the movie are already loaded. They are in the RAM. So there is really no delay in playing them. And we can actually play them all at the same time by using this message. So let's say target 1, play video, play movie 0, I guess. And then target 2, play the movie 1, or whatever. We can play another movie 3 or whatever. And in this way, it's going to create multiple targets, which are basically several textures, each one containing frames for the movies we wanted. Now it's summing them together in this P window, which is actually pretty cool, but we can actually extrapolate them. So for example, by unpacking, let's do that from scratch. We can unpack the name of those textures, which are, it's a symbol, of course. And actually, first I unpack the word, the GGL texture, the symbol GGL texture. And then I'm unpacking the name of the single texture. So that's the texture with the first video, that's the texture with the second video. And that's actually just a symbol GGL texture. So if I'm going to pack those together, for example, GGL texture and that, then we're getting the message GGL texture followed by the name of the actual texture. And we can see that now it's playing the movie number 1 here. And if I do that with the other texture, you can see that is nothing coming out because I connected it wrong. This should be gl texture symbol. Cool. Now it's playing the second video, and I can have as many movies. I have actually even more, because target represents the texture which is going to be filled with that movie. So let's say target 3. Let's play again movie 0, just to see if you're actually getting the first movie again on another target. And as we can see, it's actually working, and so on. So we can have all these movies playing at the same time, loaded from the folder, and playing all at the same time. We can play one at a time in a very fast way. We can play them all together. So this is pretty cool. Not sure it's worth to save that patch either. Cool. And then we got the gl texture set, which is actually does the same thing, but with textures. We can give it a quick look. Gl texture set. It's like gl matrix set, if you're familiar with it, but it's actually, in this case, works with textures. So I need again a git world. I need to have floating. Actually, I don't even need to have it visible. Oh, but I want to have it enabled. And we can load the folder with images here. Actually, let's check the help file. We can either, in the help file, is actually using a movie to fill a bunch of textures from this movie, which is pretty cool. And then we can play them randomly from example, for example, from the stored textures. That's a way of using it. Or otherwise, so there is this index output texture. I actually don't think that allows you to read a folder of texture. You can just feed them one by one, a bit like with the GL, with the JIT matrix set. But it will store them all as textures. For example, yeah, okay, now it will take a bit too much time to create a patch ad hoc to show that, but it's really super easy to see. What this object does in that file is actually pretty clear. You just send the index of the texture where you want to store it, and it's going to, and then you send the texture message to the object at that index, and then you send output texture to get the texture at that index. So very straightforward. Now I actually want to show you another object, which is the JIT gradient UI object, because in Max, there was not really an object to simply create gradients. So just a one-dimensional matrix with a bunch of colors in it that will span from one color to the other. So there is this object now, which is called JIT gradient.ui. And it just does what it looks like. So it's going to output a matrix with gradient ranging from those colors that we can input. So by default, it's going to be between red and green, but we can add some more of those rectangles simply by clicking on this white bar. And then we click on the rectangle, we click on these other rectangles showing the color, and we can change the color. And this is going to output the gradient. As you can see, the gradient is pretty, there are not so many cells in this matrix. Actually, we can take a look at how many cells there are using a JIT matrix. And this is a matrix that is 20 cells. Monodimensional matrix, as you can see, with 20 cells in it. So we can actually change this size of this matrix by giving it the attribute matrix or output matrix dim, actually. Output matrix dim, you can set to something like, I don't know, 512. And then, as you can see, the gradient becomes much smoother. And we can use this gradient to do whatever we wish to do with it. Actually, we can even set an alpha. So let's actually make quickly a little patch. Let's create a JIT world, enable floating, there it is. And let's create simply like a JIT multiple, GGL multiple, with just a couple of params, the position and the color of the object. Then I want to get a JIT GL grid shape as a target. Set automatic 0 color, and the color we're going to set from the GGL multiple. Okay, there it is. Let me actually get a camera just to zoom a bit out. JIT GL.camera position 005 or something. Actually, it's make 0010. Okay. And let's send then a JIT matrix with 3 planes for the position, flow 32, and let's say we want to add just 10 different objects. Create a JIT gen to just create some coordinates where to place those grid shapes. So inside JIT gen, I'm simply going to create the sign normalized coordinates. I'm going to switch the x coordinate for that. And I'm going to use it as the x coordinate for the position of those spheres. Actually, let me multiply it by something bigger, like something like actually like 10. And there we go. We have all our spheres. Let me actually attach a JIT anim to this camera, which is going to look in the center of the world, lock look. And then I'm going to simply attach a JIT anim drive with UI listening to it. This here. Cool. Now we can zoom out. And cool. Then I'm simply going to connect this gradient. This should work as the color of those cells and see what comes out. I guess I should maybe reduce the output dimension to 10. Okay. And this is actually, so this, the matrix that comes out of here should have the alpha as the first component, so in matrix form. So if we want to use this for GL objects, we should set the alpha as the latest component of the latest plane of the matrix. So by now, this matrix comes out as alpha, red, green, and blue. The planes are organized in that way. But for GGL multiple, we want to have it in RGBA format. So we can simply change this attribute alpha last, which is going to set then the alpha as the latest plane, the fourth plane, which then results in a correct color for the GGL multiple, but of course in a wrong color if we just represent this in a GTP window. And cool, we can also actually set the alpha as well for this matrix that comes out for this color. And this we can do with the, we can set the color for the single rectangles, our pointers for the colors. And so let's actually get a bit of space. So this is going to set the color for the single rectangles. For example, if I want to change the color for the first pointer here, this rectangle here, I can set actually is alpha to be something smaller. And then if I enable the blend enable, and then depth enable set to 0 for these shapes, we can see that the shapes. You can set also the alpha of those shapes using the gradient. So yeah, exactly like that. If I want to change the color of the second pointer, I just go to his index, which is just the order in which they are represented inside this bar, and I can change its color through this message. And we set his alpha to something bigger. Okay, as you can see, they are responding to the alpha and to the color. Okay, cool. Maybe this is worth saving, so I'm going to save it as gradient UI demo. And that was the gradient UI. At the moment, it's not really possible to save this object through a preset, but this is coming in a very soon future release. Another note on the face patch, I'm using, as you can see, the gl poly movie just to output the different movies at the same time instead of using a bunch of JIT movie objects, which would have been my first option. But then I thought, actually, we got gl poly movie, and it's actually super convenient to just load the movies from the folder and then play them out all at the same time from gl poly movie. And what else do we got? I think this is, no, I got still to show you what is coming up in a future release. Maybe first I pass the word again back to Matteo, and then we go back to me for the gl text. What do you say, Matteo?
Yeah, as you prefer, really. That's the same.
Cool.
As you want.
Yeah. Let's do that. So
okay.
So, and if you are good to go.
Mm-hmm. Yeah.
Okay. Oh, I see you actually wrote something in the chat.
Sorry?
Did you write something in the chat? Oh no, Matteo Nizzardo wrote something. Okay, I think we're going to answer all the questions then at the end of the presentation.
I think so. And anyway, I'm going pretty fast on this. So here we enter in the realm of things that are currently unreleased, but we are working on. So I want to show you a couple of best effects. Starting from this one. So this one is called TAA, that stands for Temporal Anti-Aliasing. Now, I assume you are quite familiar with what aliasing is and what are all the problems related to aliasing. So this temporal anti-aliasing effect is an anti-aliasing filter that works like this. Well, I don't know where to start with this. Consider this. We render a frame, okay, the current frame, and apart from showing that on the JIT window, we also store that frame somewhere in a buffer of memory. Now we go to the next frame, and once we render the current frame, that is the frame if you want t+1, we go back in the history buffer, look for that content, and we blend the result with the current frame. So by repeating this same process, after a while, the image gets super defined. So it is usually this technique is called temporal supersampling, because in fact you are supersampling the image, but without using space. So you do not render a scene that is, I don't know, ridiculously huge. You simply render the scene with the size you want, but you use time to store and refine the rendering for the current frame. This works, but of course, to gather more information for each frame, you cannot always render the same exact image, otherwise you keep averaging the same result. So for this reason, for each frame, the camera gets slightly tilted. So slightly that in fact the movement is sub-pixel, in the sub-pixel region. So if we disable this effect, probably you should be able to see that this torus is wiggling around. I don't know if you can see that, but hope you do. Anyway, so for each frame we move slightly the camera, capture that in a history buffer, and at the next frame we compute the average between the current frame and the previous frames. This way we're able to accumulate the result and get an anti-aliasing effect. And the benefits of such a filter is that it's very, very efficient. I mean, you can supersample a scene 32 times by rendering the in a window with the same dimension of the output you want. And for example, to show you better how it works, here I reduced this checkboard pattern, and you can see that we have barely some aliasing here, but the rest looks fine. But look at what happens as I disable this anti-aliasing effect. Here, all sorts of aliasing is coming up. So this is very simple as an effect. It is a pass effect, as I said before. So the idea is that you can create this GGL pass, calling this effect that will be called, I guess, TAA simply, and that's it. That's fine, and you can use it. The nice trick is with this effect is that of course it's simple to understand how it works with static scenes, but as soon as something is moving on screen, this effect keeps working because apart from taking the content of the colors of the previous frame, we also store the velocity buffers. So we know even if any shape is moved somewhere else, we know where to go looking in the history buffer for that specific fragment. So we can keep accumulating the result even if the object on screen is moving. So this is one of the pass effects we are working on. And another one I'd like to show you somehow is based on the same concept of temporal supersampling, but does something different. It is related to screen space ambient occlusion. So let me pick that very quickly. Okay, here it is. So, okay, let me change a couple of things. Okay, maybe you are already familiar with ambient occlusion. This is an effect, a post-processing effect that gets applied to a rendered scene, and it lets you it lets you find all the parts of the scene where you have concave shapes. And as I said previously, for gl.pbr, all these parts are not supposed to receive as much light as, let's say, this convex part. So usually this is computed in screen space, casting a bunch of rays that test for each fragment the distance to the neighboring objects. If an object is close enough, then the occlusion factor is increased. Otherwise, if a ray, let's say starting from this cube and going out there, doesn't emit anything, it means that this part of the cube is supposed to receive maximum amount of light. But the nice thing with this new approach to screen space ambient occlusion is that you can create the same super sampling. So here, this is how a standard screen space ambient occlusion looks like. But if we increase this accumulation value, we go looking in the history buffer for what we already computed, so nothing gets wasted, and the solution is continuously refined. So using the very same approach, something else we can achieve is a sort of global illumination. So typically in a rendering like this, each object gets colored on its own, so it does not interact, let's say, this cube again with this torus. They don't know about each other's existence. But through this effect, while we are testing the distances, we can also go and check in the neighborhood what are the present colors. And the effect of doing this is that now every object contributes to the lighting of the scene. You can see that here on the floor we have something purple, here something green, while if we disable this effect, we don't. Or look at the face of this statue, with and without global illumination. So basically the effect is that of the light bouncing off all these objects and going to illuminate the rest of the scene. And the nice thing about this approach is that you can also create emissive materials. So using the same concept, you can say that, okay, this source, I want it to behave like a light source. So you simply color it with a more intense light, and that's it. Every other object that is close to it receives this amount of lighting. So this was an old prototype. I'd like to show you where we are at now, because we decided to add a couple of other features. So let me pick it. Okay, it should be this one. All right, enable the rendering. Okay, no. Here we have a giant duck in the middle, but that was not intended. So, okay, let me read another Okay, another 3D object. Okay, fine. So what's the difference between these and what you saw previously? Now, apart from ambient occlusion and global illumination, we also introduced screen space reflections. So as you can see, let me stop this camera moving. And let's zoom in manually. You can see that, for example, this B ladder that is now emitting light is reflected on the floor, as well as all these other objects now have this nice reflection. And apart from ambient occlusion, screen space reflections, we are also going to implement screen space shadows. Which is another thing. I cannot show you right now because it's super sketchy and it doesn't look great, but we are planning to include that as well. So again, this will take the form of a GGL pass effect. So as always, you render the scene that would look something like this, and then you apply this pass effect that will make it look something like this. And at the moment, you're seeing this screen space ambient occlusion in conjunction with temporal anti-aliasing, which, by the way, helps in refining the solution for all these ray tracing systems. And yeah, that's it. I mean, that's what I can show you right now, but there are so many other things we're working on, and I'm sure you will be excited, as I will do, whenever we will able to release those. So again, maybe now I pass it over to Federico, who shows you something else.
Thank you, Matteo. Yeah, this looks super cool. Actually, looking very much forward to play with that. And okay, so let me show you the last thing for today on my side, which is the multiple gl.text.multiple. So basically, the possibility of creating multiple 3D text in a scene without having to manually create a bunch of GGL text objects, and also allowing for this text to be rendered, maintaining a decent frame rate. As you can see, I'm now at 200 frames per second. So let's see how this works. Basically, it's designed to work the same way as GGL multiple. So you can feed it with matrices, and it's going to place the objects at for example, the position. Is going to scale them, is going to rotate them according to how many parameters you want to use. For example, let's say I want to actually use just 4 parameters. So I'm going to say I want to have only 4 GL params, which is going to be the position, the scale, the rotation, and the color. Then I'm going to fill those matrices with a bunch of noise. So this is for the position, this is for the scale, this is for the color, and the rotation is automatically being updated, as you can see. And we can also assign a material to gl.text.multiple. So for example, at the moment, if you assign a material, it's going to delete the actual color of the objects, but if we set material known, it's actually going to keep the color and assign just a basic material. And in this way, we can send a text like we will do to a GGL text object. But in this case, the text is composed of several words, and all the words are going to be spread through the objects. For example, I now have 10 objects. So these, let me actually stop the rotation for 1 second. Let's recreate that. Oops, I sent it again. Sorry, let's actually get it to the, yeah, let's keep it to 4, and position, scale, rotation, it's not attached anymore. So yeah, it should be good. Oh, right, it's keeping the rotation. Okay, there's still quite some work to do on this, but let's see. Okay, now should be okay. So, exactly. So the words are going to be spread to those objects, which can then be updated their position. We can change the words they are representing. And let's say we want to create a bunch of those, for example, 100. It's going to take 1 second to initialize the actual the actual gl text objects under the hood, then we can actually, every time we feed a new text, we need to recreate those objects. So it's going to take a while. But then we got all the words that we want. Let's try to have more. Let's try to have 400. That's going to definitely take a couple of seconds, maybe 20 seconds or something. So we can just look at each other in the eyes. 20 seconds. Or maybe it's, yeah, I mean, actually was slightly faster. So now we got all those, by default, it's going to render the word test. We could replace that with numbers. Every time, again, it needs to actually recreate the objects from scratch. Every time we update the words, unfortunately. That's kind of the drawback for these objects. Okay. Oh, now it only filled 100 of them with words, and the others, it's kept the word test. But okay, I guess you got the idea. So in this way, it's actually possible to work also with physics and test, which was not really possible or easy to do before. We can have this test being continuously moved, for example, by some paddling noise. And yeah, this is a feature that I think it's going to, we think it's going to be pretty funny for you to try that. And we hope to actually release that pretty soon. Cool. So that was it for me. I think we exhausted all the list of objects that we got for Jitter 8.3. So yeah, I'm going to stop here.
That's so cool. I didn't see yeah, the ladders rotating. I didn't know it was something you figured out how to implement. Yeah,
that's the latest edition. Was actually pretty straightforward.
Nice.